So this video, I'll show you how to draw 3D representations of molecules on paper. So we got to do this in a 2D space, so that means we have to employ some tricks. So here's our good old friend, CH4, yet again, showing up one more time here. And so what we have is we have our central carbon, and then when we draw a line like normal for a bond, this is still a bond, but it just means that it's flat with respect to the surface of our paper or, our screen or whatever we're looking at. But what's new is we have this wedge and this dash. And so these are still single bonds right here. So it's all four of these hydrogens single bond to the carbon, just like we've seen a million times before. But now this is a 3D representation. And so we're not going necessarily up, down, left, right, but we're going about 109.5 degrees between our bonds. That's what we're showing here. And then these wedges mean that it is coming out towards us, and the dashes mean it's going back. And so to help illustrate this point, I'll fire up Mole View here in a second, but this is the 3D representation of CH4. And so if we look at it, here's our Lewis structure we've seen a million times. And then on the right-hand side, we've got our 3D structure that we can rotate around. So, I mean, this is, a 3D representation of it, but how do we get this 3D representation onto a flat surface? Well, typically you want to rotate it so that you have, this doesn't always rotate easy. Two bonds that are flat to the surface, and then what we have here is something that's sticking out. I'm going to tilt it back a little bit here so we can see we got this hydrogen that's bonded going back. And so we'd represent this forward hydrogen with a wedge, and this back one here with a dash, and this would be a line, and this would be a line. And generally you want to try to maximize as many flat lines as you can because they're easier to draw. It's easier to conceptualize. So if you have a molecule that's totally flat, you just draw, it basically looks just like the Lewis structure. You just draw it flat. Now what I have here is a little different than over here. It's the same molecule, but I have the single bond to the right being flat, and then I have front and back on the left. But in this case, all I have to do, this is the beauty, is I just rotate. I just rotate it. Now I have the flat bonds up and to the left, and then I have a wedge and a dash. And so that's what it's showing here. So that could be a little bit tricky sometimes in the fact that you can kind of rotate. And sometimes people do crazy stuff, like you can do like wedge, 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 dash going back. But generally, like I said, try to get as many straight lines as possible. That's definitely going to keep SmartWork happy if you have to enter any of these. And so, if I use my molecular modeling software here, I take my drawing, and I need to make a drawing from what I'm seeing here. Well, I just arrange it again, two flat lines, and then I come over here, and, okay, so I do my central atom. So I've got a carbon, and then I had a hydrogen that was straight up, and a hydrogen that was about 109.5. You don't have to be perfect that away. And then let's go back and look here. Okay, so I've got a wedge and a dash. So I go, just make a wedge. Do the best you can. Wedge. And then, dash. I'm doing this with the mouse, so it's extra not perfect. But that would work. Like, that's our 3D representation. That's what we're working with. Now, if we have something that has some, lone pairs in it, a little bit different geometry, like, for example, let's do NH3. Okay. Bring that up in 3D. So now I only have three groups bonded, but they're not flat, so I don't want to do three straight lines. But I could do something like this, in which case I have a line and a line. We'll say these are, flat to the surface. And then I have a wedge, or I could rotate it. And I can have, oh, come on now. No need to be so difficult. We'll just kind of mix it up here. We'll see if I can get this. Alright, that's what I had before. Okay, and so, if these are flat, then I have line, line, and dash. And so I like to draw wedges more. I don't know, I have an easier time with them. So we're going to go with this conformation. Just kind of get it where I want it. Alright. And let me clear this out here. And so now we have a nitrogen as our central atom. Alright. And what have I got? I've got up and to the right are lines. Okay. And it's not flat, so I don't want a line here, but what I have is a wedge. Alright, we'll fill that in. We got an H. And, we can put the lone pair. You don't generally, like, draw the lone pair. We're not going to do, like, a big bubble here, because there's no way to make that 3D, drawing back. Like, you don't do, like, a dashed lone pair or something like that. So generally, you just draw the lone pair as a pair of dots, if at all. And if there's ever any double or triple bonds, my best advice I can give you is don't try to do a triple wedge or a triple dash. Keep those flat. That's the priority. You're no longer trying to maximize the number of lines that we have flat, but that the double and triple bonds are staying flat. So for example, if we look at one more, do carbon, carbon, and then we'll do a double bond here. Okay, bring that into 3D. Now here's the beauty of this molecule. Flat as a pancake. So I can do the whole thing with just regular lines, just like that. So I can go to my drawing here, and we can go carbon, double bond, carbon, and then we're doing a 3D drawing, so we kind of want to estimate, even though it's flat as a pancake, we want to get these bond angles approximately right. So they're about 120. So don't go straight up, straight down, but instead make it about 120 degrees. So no 90s or 180s. Okay. So that's what we're looking at. Now you don't want to do anything crazy. Sometimes students like to, I don't know, look down the way, and it's like, oh, I have a bunch of dashes and wedges. And, oh, no, look at that. Boom. All lines. Piece of cake, right? Keep it simple. And, if we start stacking on more carbons, get something a little more complicated, what we would do is arrange it so that we can get it as flat as possible. Now, the nice thing about model kits is you can rotate these bonds, and I don't think there's a tool for that in MoldView, but generally you can actually get this whole carbon structure to be flat, so you don't have anything too crazy. But just do the best you can, and definitely, like I said, don't be doing double wedges, double dashes. That's the big thing to avoid there. All right, so as it gets more complicated and get a little trickier, it's a good tool to understand. Very important for organic chemistry because it starts being molecules like this that you got to look at in 3D space. And how do we do that on our notes? How do we do that on a piece of paper? Well, the answer is wedges, dashes, and lines. That's how we do it. And so that's whenever you're asked for a 3D drawing, don't be, drawing spheres and perspectives and all that stuff. No, you just do letters with lines, wedges, and dashes. That's all there is to it.